Welcome to our channel Circuits Analytica. In this video, we will discuss a tutorial on nodal analysis. For the following network, find Vx, where Vx is the voltage drop across 100 ohms resistor. First step is to mark the nodes of the network as P, Q, S, T and R. Mark currents associated with various nodes P, Q, S and T. Apply KCL at node P. There are three currents associated with node P. The three currents are I1, I2 and I3. Current I1 is incoming while the other two currents are outgoing. Therefore, according to KCL, we can write I1 is equal to I2 plus I3, where I1 is equal to 10 ampere, I2 is equal to Vp by 20 and I3 is equal to Vp minus Vq divided by 40. Applying KCL at node P, we will get I1 is equal to I2 plus I3. Vp by 20 plus Vp minus Vq by 40 is equal to 10. Taking LCM as 40. 2Vp plus Vp minus Vq, the whole divided by 40 is equal to 10. 3Vp minus Vq is equal to 400, equation number 1. Apply KCL at node Q. There are three currents associated with node Q, I3, I4 and I5. Here I3 is the lone incoming current while I4 and I5 are outgoing currents. I3 is equal to Vp minus Vq, the whole divided by 40. I4 is equal to Vq by 100 and I5 is equal to Vq minus Vs, the whole divided by 50. So applying KCL at node Q, I3 is equal to I4 plus I5. So Vp minus Vq, the whole divided by 40 is equal to Vq by 100 plus Vq minus Vs by 50. Rearranging the terms, we can write Vq by 100 plus Vq minus Vs by 50 minus inside bracket Vp minus Vq by 40 is equal to 0. 2Vq plus 4Vq minus 4Vs minus 5Vp plus 5Vq, the whole divided by 200 is equal to 0. Rearranging the terms, we will get minus 5Vp plus 11Vq minus 4Vs is equal to 0, equation number 2. Apply KCL at node S. There are four currents associated with node S. I5 and I8 are the incoming currents while I6 and I7 are the outgoing currents. I5 is equal to Vq minus Vs, the whole divided by 50. I6 is equal to Vs minus Vt, the whole divided by 10. I7 is equal to 2.5 ampere and I8 is equal to 2 ampere. Therefore, according to KCL, we can write I6 plus I7 is equal to I8 plus I5. Vq minus Vs, the whole divided by 50 plus 2 is equal to Vs minus Vt, the whole divided by 10 plus 2.5. Rearranging the terms, we can write Vq minus Vs, the whole divided by 50 minus of inside bracket Vs minus Vt, the whole divided by 10 is equal to 0.5. Vq minus Vs the whole divided by 50 minus of inside bracket Vs minus Vt the whole divided by 10 is equal to 0.5. Opening the brackets, we will get Vq minus Vs the whole divided by 50 minus Vs by 10 plus Vt by 10 is equal to 0.5. Taking LCM as 50. Vq minus Vs minus 5Vs plus 5Vt the whole divided by 50 is equal to 0.5. Rearranging the terms, we will get Vq minus 6Vs plus 5Vt is equal to 25, equation number 3. Apply KCL at node T. There are 4 currents associated with node T. These 4 currents are I6, I9, I8 and I10. Out of these 4 currents, there are 2 incoming currents and 2 outgoing currents. The 2 incoming currents are I6 and I9, while the 2 outgoing currents are I8 and I10. I6 is given as Vs minus Vt the whole divided by 10. I8 is equal to 2 ampere, I9 is equal to 5 ampere and I10 is equal to Vt divided by 200. So applying KCL at node T, we will get I6 plus I9 is equal to I10 plus I8. Vs minus Vt the whole divided by 10 plus 5 is equal to Vt by 200 plus 2. Rearranging the terms, we will get Vs minus Vt the whole divided by 10 minus Vt by 200 is equal to 2 minus 5. 20 Vs minus 21 Vt is equal to minus 600, equation number 4. So we have 4 equations. 3 Vp minus Vq is equal to 400, equation number 1. Minus 5 Vp plus 11 Vq minus 4 Vs is equal to 0, equation number 2. Vq minus 6 Vs plus 5 Vt is equal to 25, equation number 3. 20 Vs minus 21 Vt is equal to minus 600, equation number 4. So consider equation number 1, 3 Vp minus Vq is equal to 400. So 3 Vp is equal to 400 plus Vq. Therefore we can write Vp is equal to 400 plus Vq the whole divided by 3. Equation 1.2. Substitute equation 1.2 in equation 2. Equation 2 is minus 5 Vp plus 11 Vq minus 4 Vs is equal to 0. Substitute Vp is equal to 400 plus Vq by 3. We will get minus 5 into inside bracket 400 plus Vq the whole divided by 3 plus 11 Vq minus 4 Vs is equal to 0. So minus 2000 minus 5 Vq plus 33 Vq minus 12 Vs the whole divided by 3 is equal to 0. 28 Vq minus 12 Vs minus 2000 is equal to 0. 28 Vq minus 12 Vs is equal to 2000, equation 2.1. So now we have 3 equations. 28 Vq minus 12 Vs is equal to 2000, equation 2.1. Vq minus 6 Vs plus 5 Vt is equal to 25, equation number 3. 20 Vs minus 21 Vt is equal to minus 600, equation number 4. Let us rearrange these equations as 28 Vq minus 12 Vs plus 0 Vt is equal to 2000. Vq minus 6 Vs plus 5 Vt is equal to 25. 0 Vq plus 20 Vs minus 21 Vt is equal to minus 600. In matrix form, these equations can be written as matrix of 28 minus 12 0, 1 minus 6 5, 0 20 minus 21 into matrix of VQ Vs Vt is equal to matrix of 2025 minus 600. Vq is equal to delta 1 by delta, where delta is equal to determinant of 28 minus 12 0 1 minus 6 5 0 20 minus 21, and delta 1 is equal to 2000 minus 12 0 25 minus 6 5 minus 100 20 minus 21. So we will get delta is equal to 476 and delta 1 is equal to 81,700. Therefore, we will get Vx is equal to Vq is equal to delta 1 by delta. Vx is equal to Vq is equal to 81,700 the whole divided by 476. So we will get Vx is equal to 171.63 volt. Thanks for watching Circuits Analytica. Enjoy learning.